Welcome to today's explainer. So, have you ever stopped to wonder how your body knows exactly when to start shivering on a brisk winter day? Or, how it knows the exact millisecond to release a flood of stress hormones right before you step up for a big presentation? You don't consciously think about these things, do you? They just kind of happen. Well, today we're uncovering the ultimate background operator making all of that happen. We're talking about the hypothalamus. It's this incredibly powerful structure that weighs about 4 grams, which, to put that into perspective, is less than a teaspoon of sugar, yet it controls almost everything you do. Okay, let's dive right into this. Our agenda today covers 5 main areas: the body's smart controller, the anatomy of the hypothalamus, the hormone command center, autonomic and emotional integration, and finally, we'll look at what happens when there's a system failure. Section 1. The body's smart controller. To really grasp what the hypothalamus does, we need to shift our perspective just a bit. Try to think of your body not just as a biological machine, but as a highly complex house that requires constant 24/7 management to keep everything running perfectly. I absolutely love this quote from the Cleveland Clinic because it hits the nail on the head and sets up our overarching metaphor for today perfectly. Your hypothalamus is basically your body's smart home hub. It manages your internal thermostat, your security alarms, your daily sleep-wake timers, and even your internal plumbing. And the crazy part, it does this all completely automatically, without you having to lift a single finger or consciously think about it. So the absolutely crucial overarching concept here is homeostasis. This is the primary goal of the hypothalamus. It's the holy grail, really. Every single action it takes, every chemical it releases, is a precise calculation designed to keep you in this perfect biological balance. It is constantly receiving sensory information from all over, comparing it to your body's ideal set points, and making continuous microscopic adjustments. Section 2. Anatomy of the hypothalamus. Now, what's really interesting about this slide is where the hypothalamus actually sits. As you can see, it's this tiny almond-sized structure sitting deep, deep within your brain. It's located just below the thalamus and right above the pituitary gland, which is that little drop-like structure hanging just beneath it. Keep that physical connection in mind, because that direct link to the pituitary gland is going to be incredibly important in just a few minutes. Think of this table as a floor plan for our biological smart home. The hypothalamus isn't just one uniform lump. It's like a giant puzzle divided into distinct regions or rooms called nuclei, and each room has a totally different job. Take a look at the anterior region. This is where your body handles cooling down by promoting sweating, and it manages your circadian rhythm, literally syncing you with day and night. Moving to the middle region, well, this is the kitchen of the smart home. It regulates appetite and, crucially, satiety, telling you when you're full. Finally, the posterior region. While the anterior cools you down, the posterior heats you up by triggering shivering when you're cold. It is an incredibly organized division of labor. Section 3. The hormone command center. So, we know where the rooms are, but how does this tiny little almond actually send its commands to the rest of the massive human body? Well, it communicates primarily via hormones, interacting with that pituitary gland hanging right below it in 2 very distinct ways. The anterior pituitary is controlled via a network of blood vessels. Think of this like the hypothalamus sending a chemical email. It drops releasing hormones into the blood, which travel down to the pituitary to tell it what to do next. But the posterior pituitary? That's totally different. The hypothalamus is physically hardwired into it via neural tissue. It actually produces hormones like oxytocin and vasopressin up in the hypothalamus, sends them down long cables, and simply stores them in the posterior pituitary until it's time to release them. It's an amazing piece of wiring. And this brilliantly illustrates one of the key ways those stored hormones are used. What we're looking at is a positive feedback loop involving oxytocin. When a baby suckles, mechanical nerve signals are sent straight up to the mother's hypothalamus. The hypothalamus responds by firing bursts of oxytocin from that posterior pituitary right into the blood. That oxytocin then causes the breast tissue to contract, forcing milk to flow, which leads to more feeding, which, you guessed it, leads to more oxytocin. It's a continuous, powerful go signal. But, of course, the body can't just operate purely on go signals, right? It needs breaks. This outlines a negative feedback loop, specifically the HPA axis that manages stress. Let's walk through it. When you're stressed, step 1, the hypothalamus releases CRH. Step 2, that tells the pituitary to release ACTH. Step 3, that tells your adrenal glands to release the stress hormone cortisol. But here is the absolute genius part, step 4. When cortisol levels in the blood get high enough, that cortisol physically travels back up to the hypothalamus. The hypothalamus senses the high cortisol and effectively says, okay, message received, we have enough stress hormone running through the system, and it shuts the whole alarm system down. It's a built-in thermostat for your stress.
Section 4. Autonomic and emotional integration.
Now we're shifting focus to the security and alarm functions of our smart home, because the hypothalamus is the literal bridge between your mind and your body. Think about it. When you encounter a threat, another part of your brain called the amygdala processes the actual emotion of fear. But you don't just think fear in your head, you feel it in your whole body. Why? Because it's the hypothalamus that receives the panic signal from the amygdala and translates it into physical reality. It is the exact reason why feeling afraid makes your heart race, your pupils dilate, and your palms get super sweaty. And it executes all these physical changes through completely automatic control. For instance, the lateral zone of the hypothalamus is essentially the trigger for the sympathetic nervous system. That's your intense fight or flight response, mobilizing energy to keep you safe. Conversely, the anterior hypothalamus acts as the parasympathetic brake, promoting the rest and digest state to calm your body down and conserve energy once a threat has passed. It integrates your internal, emotional reality with your physiological state seamlessly, all behind the scenes.
Section 5. When the system breaks.
Now, like any incredibly complex smart home loaded with millions of wires and sensors, a damaged wire can cause catastrophic systemic issues. And the causes for a power outage or hypothalamic dysfunction are surprisingly diverse. Because it sits right at the base of the brain, a traumatic brain injury, a tumor on the pituitary gland right below it, or even radiation therapy can damage this tiny little structure. Even severe nutritional deficiencies like anorexia can cause it to stop signaling properly. And because it controls so many different axes, thyroid, growth, reproduction, stress, the symptoms vary wildly depending on exactly which specific cluster of neurons was damaged.
To really understand the real-world impact of a broken hypothalamus, let's contrast these two profound conditions. On the left, we have Prader-Willi syndrome, which is a genetic disorder where the hypothalamus literally fails to recognize the sensation of fullness. The satiety alarm is entirely broken, leading to a constant, insatiable urge to eat. Now contrast that with diabetes insipidus. This is a condition where the hypothalamus fails to produce enough vasopressin, the antidiuretic hormone. Here, the plumbing system breaks, causing the kidneys to just flush water out, resulting in dangerous dehydration and extreme thirst. These are two completely different, life-altering conditions, and yet they both stem from microscopic errors in the exact same almond-sized part of the brain. So all of this leaves us with a pretty fascinating final thought. We really like to think of our conscious, rational minds as being behind the steering wheel of our lives, right? But if an almond-sized cluster of neurons operating entirely in the background dictates when you feel hungry, how your body physically reacts to stress, your core temperature, and even how your deepest emotions physically manifest, well, who is really in control? It's a wild question to ponder, and one that highlights just how absolutely incredible the human body truly is. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.